Now let's see about software project management. Fifth unit is a software quality assurance. This unit contains quality requirements, the SCI CMM guidelines, challenges, quality function, deployment, building the software quality assurance, plan, software configuration, management principle, and requirements. Let's see about one by one. The software quality assurance. Software quality assurance is the ongoing process that ensures the software product meets. Software quality assurance is a set of activities that verifies that everyone involved with the project has correctly implemented all procedures and process. Next thing, quality requirements. Uh, Prepare an SQA plan for your project. The plan is developed during project planning and reviewed by stakeholders. The plan governs quality assurance activities performed by the software engineering team and the software quality assurance group. The plan identifies calculation to be performed, audits and reviews to be performed, standards that apply to the project, techniques for error reporting and tracking, documents to be produced by the software quality assurance team, and amount of feedback provided to the software project team. Next one, participates in the development of the project's software process descriptions. The software team selects a process for the work to be performed. The software quality assurance group review the process descriptions for compliance with organizational policy, internal software standards, externally imposed standards, and other parts of the software project plan. Next one, project review engineering activities to verify compliance with the defined software process. The software quality assurance group identifies, reports, and tracks develop deviations from the process and verifies that corrections have been made. Audit designated software work products to verify compliance with those defined as a part of the software process. The software quality assurance group reviews selected work product, identifies documents, and tracks deviations, verify that corrections have been made, and periodically reports the results of its work to the project manager. Next one, ensures that a deviation in software work and work product are documented and handled according to a document procedures. Deviation may be encountered in the project method, process descriptions, applicable standards, or technical work products. Next one, records any non-compliance and reports to sensor management. Non-compliance items are tracked until they are resolved. Next, we'll move to the SCI CMM guidelines. Now, the Software Engineering Institute Capability Maturity Model, that's a CMM, Capability Maturity Model, specifies increasing series of levels of a software development organizations. The higher the level, the better the software development process. Hence, reaching each level is expensive and time-consuming projects. The diagram shows how to develop the CMM level. First level, initial, managed, defined, measured, and optimizations. First level, initial. The software process is characterized as inconsistent and occasionally even chaotic. Defined process and standard practice that exist or abandoned during a crisis. Success of the organization majorly depends on individual effort, talent, and heroics. The heroes eventually moves on to other organizations, takes their wealth of knowledge or lessons learned with them. And next one, level two, repeatable. Uh, a repeatable level of software development organizations has a basic process and a consistent project management process to track cost, schedule, and functionality. The process is in place to repeat the earlier success on project with similar application. Program management is a key characteristics of a level 2 organization. Next, defined, and the software process for both management and engineering activities are documented, standardized, and integrated into a standard software process for the entire organization, and all project across the organization use an approved tailored version of the organization's standard software process for developing, testing, and maintaining the applications. Next one, managed. Management can effectively control the software development effort using precise measurement. At this level, organization set a quantitative quality goal for both software process and software maintenance. At this maturity level, the performance of process is controlled using statistical and other quantitative techniques and is quantitatively predictable. Next one, optimizing. The key characteristics of this level is focusing on continuously improving process performance through both incremental and innovative technological improvements. At this level, changes to the process are to improve the process performance and at the same time maintaining statistical probability to achieve the established quantitative process improvement objectives. And next, we'll move to quality function development. Quality function development. The model aids in translating customer needs and expectation into technical requirements by listening to the voice of customer. Interrelationship of design features, how to meet the customer wants, customer needs, and a comparison of customer priorities and benchmark target value. Quality function deployment was developed in late 1960 is by Japanese planning specialist named Yoji Ako. QFD, quality function deployment, aims at translating voice of customer into measurable and detailed design targets and then drives them from the assembly level down through sub assembly level, compound level, production process level. Next, quality fundamental deployment, quality function deployment helps to achieve structured planning for product by enabling development team to clearly specify customer needs and expectation of product then and then evaluate each part of the product simultaneously. Yes, what are the key steps in QFD? Product planning, part planning, process planning, and production planning. First one, product planning. Translating what customer wants or needs into set of prioritized design requirements. Prioritized design requirements describe looks or design of product. Involves benchmarking, comparing products performance with a, competitor's product, setting target for a improvement and for achieving competitive edge. Next one, part planning. Translating product requirements specifications into part of characteristics. For example, if requirements is that a product should be portable, then characteristics could be lightweight, small size, compact, and etc. Next one, process planning. Translating part characteristics into an effective and efficient process. The ability to deliver Six Sigma quality should be maximized. Like product planning, translating process into manufacturing or service delivery methods. In these steps to our ability to deliver Six Sigma quality should be improved. Next thing, benefits of QFD. Customer focused, voice of customer competitive analysis, structure and documentation, low development cost, shorter development time. Next, customer focused. A very first step of QFD is marketed by understanding and controlling all user requirements and the expectation of product. The company does not focus on what they think customer wants. Instead, they ask the customer and focus on requirements and expectation put forward by them. Next one, voice of customer competitive analysis. House of quality is a significant tool that is used to compare voice of customer with the design specifications. Next one, structure and documentation. Tools used in quality functions deployment are very well structured for capturing decision made and a lesson learned during development of product. This documentation can assist in development of future product. Next, low development cost. Since QFD focuses on the pays close attention to customer requirements and expectation in sales steps itself, so the chance of a late design changes or modification are highly reduced, thereby resulting in a low product development cost. Next one, shorter development time. QFD process prevent wastage of time and the resources. Enough emphasis is made on customer needs and wants for the product. Since customer requirements are understood and developed in a right way, so any development of non-value added features or unnecessary functions is avoided. Resulting is in no time waste of product development team. Next, we'll move to plan. Software quality assurance plan comprises of the procedures, technique, and the tools that are employed to make sure that a product or service align one with the requirements defined in the SRS. SRS means software requirement specifications. This is software development. The diagram shows how to develop. The plan identifies the SQA responsibilities of your team, lists the areas that need to be reviewed and audited. It also identifies the software quality assurance work products. Software quality assurance plans have variable formats, but in almost every case, we can find these constituents: introduction, a reference document, management, document, standard, practice, convention, and metrics, review and audit. Next one, we'll move to software configuration management principle. Software configuration management principle. Software configuration management principle is a process to systematically manage, organize, and control the challenges in the document, code, and other entities during the software development life cycle. The primary goals is to increase productivity with minimal mistakes. SCM is part of cross-disciplinary fields of configuration management, and it can accurately determine who made which revisions. Next one, software configuration management process. Software configuration management process, configuration identification, baselines, change control, configuration status accounting, configuration audit, and reviews. First one, configuration identifications. Software configuration identification is a method of determining the scope of the software system. With the help of these steps, we can manage or control something even if we don't know what it is. It is a descriptions that contains the SC, CSCI check, that means a computer software configuration item, project identifier, and version informations. Next one, baseline. Baseline is a formally accepted version of a software configuration item. It is designated and fixed at a specific time while conducting the ACM process. It can only be changed through a formal change control procedures. Next one, change control. Change control is procedural method which ensure quality and consistency when changes are made in the configuration object. In this step, the changes request is submitted to software configuration manager. Next one, configuration status accounting. Configuration status accounting track each release during the SCM process. This stage involves tracking what each version has and the changes that lead to this version. Next one, configuration audits and reviews. Configuration software audit and reviews in this stage. Software configuration audits verify that all the software product satisfies the baseline needs. It ensures that what is built is what is delivered. Next, we will move to requirement of software configuration management. Identification, control, audit, status accounting are the basic requirements for software configuration management. First one, identification. Each software part is labeled so that it can be identified. Furthermore, there will be different versions of the software parts as they evolve over time. So, version revision number of will be associated with the part. The key is to be able to identify any and all artifacts that compose a released configuration item. Think of this as bill of materials for all the components in our automobiles. Next one, control. In the context of configuration management, control means that proposed changes to a CA are reviewed and, if approved, incorporated into the software configuration. And the goal is to make an informed decision and to acknowledge the representations associated with the changes to the system. These changes may impact budget, schedule, and associated changes to other components. Next, auditing. Auditing on SCM system means that approved request changes have indeed been implemented. The audit allows managers to determine whether software evaluation is the processing both logically and in conforms with the requirements for the software. The ACM system should document changes, version, and release information for all components of each configuration item. When such document is in place, auditing becomes a straightforward analysis task. Next, status accounting. Reports and documentation produced by the status accounting function are the auditable entries. All upload parts of a software configuration must be accounted for. and the software parts list must reflect the transmission from the part CIN to CIN plus 1. This is counting provides a historical information to determine both what happened and when on the software project. Status accounting enables the auditing requirements of the SCM. As a project manager, the status accounting holds a wealth of information on the amount of effort required throughout the life cycle of the product in its development and maintenance.